Hey everyone, welcome back. I hope everyone's having a fun and interesting time. So I'm Neeti and I'll be hosting this session. Before we go ahead, please feel free to ask questions either directly on the chat or via Q&A. Right now we have Gunnard here with me. He's going to take a session today on Introduction to OWASP. So Gunnard is a seasoned developer and an admin. He started back in the dot-com boom and has ever since grown alongside the internet, from installing Slackware on floppy disks to modern-day Docker plus cloud configurations. So over to you, Gunnard.
Hey, thank you for that. And yeah, basically what that intro means is that I'm old and I've done a lot of things. So that's why I get to talk to you today about one of my passions, which is security. And being a developer, security nowadays especially, it really goes hand in hand, because if an attacker is attacking my software, well, guess who's the person that wrote it and could have stopped some of this happening. So anyways, I've been watching the speakers all day long, and it's been awesome. We've been hearing a lot about like systems and analysis and how to navigate and set up all these scripting for these big automated tests and how to manage all that stuff. So what I want to get down to here is one of the aspects of what you might be testing is security. And the thing about the big systems that everyone here is working on and interested in is that typically the code is going to be the same across all our systems. So if you find a bug or a flaw in one of these, it's going to be everywhere. So you might not necessarily need to attack all of your systems with, injections. Just one would work and you'd find that bug in everything. But might be getting ahead of myself a little bit. Let's get into the show here. Here we go. All right. So this is Introduction to OWASP. If you're in the wrong room, then, well, stay here because you're going to learn something, hopefully. But what I'm going to tell you about today is OWASP. Hopefully either introduce you to it, you've never heard of it, or if you have heard of it, I'm just going to go over a few things that you might not know about already. So let's go. So who am I? Everybody, we have to do this. Let's get this out of the way first. I'm Gunnard Engebreth. I'm from Atlanta, Georgia. I'm living in Madison, Wisconsin with my wife. We have a son on the way. He's coming next month. You can hit me up on Twitter at Gunnard, Instagram, Gunnard, Gunnard@gmail.com. It pays to have a unique name and also get in on Gmail when it first started. So Gunnard@gmail.com. Also, I do writing. I do things. So I wrote several articles for this magazine, PHP Architect. It's behind a paywall, so you can't really find it online. But I also have, from A Press Publishing, a book that just came out, PHP 8 Revealed, because I'm a PHP developer at heart. So I do writing. I like to teach. I like to do talks. I've given this talk several times. But that's a little bit who I am. You can find me on the internet. Just type in Gunnard Engebreth. You'll find me. All right. So what are we going to go over today? So just get basis, what is OWASP, the history, how they came to be, who they are, and what they stand for, so that you really know who this group is. We're going to go over one of their flagship projects, which is the OWASP Top 10. This is kind of like your late night show top 10 list, but it's not funny at all. It's really serious, and you should be familiar with it and know how to use it, know how to look it up, know where it is, and just know how to understand it. We're going to go over a little bit in depth one of them. We're going to talk about prevention, how to use this information to be proactive, and how that's better than being reactive. We all can kind of, I hope, collectively say that being proactive is better. And then we're going to get into the mind of an attacker. This is kind of like your QA team plus. We're going to go a little bit beyond that. And I'm going to show you guys this thing called the Juice Shop, which OWASP makes. They put it out. And then we're going to get into OWASP Zap, which is kind of like, if you're familiar with any of the security software like Burp or Metasploit, Zap is OWASP's version of that. It's got a nice GUI. Of course, it's free. Everything here is open source and open to the world. Then we'll just have some QAs and we'll talk for a second. All right. OWASP. The Open Web Application Security Project. There, I know you've been wondering what the heck that means. So there it is. Basically, open web security. Why not? Share your information, get it out there, keep it public, and let's make our projects and applications better. Why not? So the foundation was launched in 2001, and they became incorporated as a nonprofit in the US 2004. And here's the principles. Open. Everything at OWASP is radically transparent, from the finances to the code. They're global. Anyone around the world is encouraged to participate in OWASP community. Go on the website, be in the forums, talk, email lists, everything. Innovative. They are interested, of course, with the newest, latest, and greatest stuff. They're very interested in, as soon as cloud became cloud, they're there. They're up to date with everything. Integrity. In the security community, integrity is everything. You do not just release out a bug or an exploit that you find on the internet in the wild. You have integrity. You go through either bug bounty programs or through the corporation's bug system that they have. You don't just release things. So things here are kept at a high standard. All right, so what is the top 10? I said it was their flagship project. They have several of them, but the top 10 is really a standard of awareness document for developers and web application security. It represents a broad consensus about most critical security risks to web applications. So what they do is about every 5 years or so. The last one came out in 2017. Every 5 years or so, they get together with about 400 different companies, people in the community, and they look at all the CVEs, all the bugs, all the exploits that have been out there, and they group them together so that they rank them. So that there's just a list that they have of what's going on, what's been happening, what they're seeing happen now, and what they can kind of predict is going to happen in the future. So like I said, the last one came out in 2017. I would expect one coming out within the next year with, how much stuff has changed since 2017? Everything. So I would expect one coming out pretty soon. So basically, these are ideologies and concepts. These are not individual CVEs. These are not specific exploits for one piece of software or one system or one method or one attack vector. These are concepts. They're platform agnostic. So they go above, this is like your 30,000 foot view versus your, Microsoft Active Directory exploit. Multi-departmental impact. We'll get into it again, but these, when they are listed, they go through, so development, development will be impacted because we'll get in touch with databases. These databases will interact with marketing. Marketing will talk about sales, and sales will, be impacted because of this. So they talk about how your entire corporation, your company, your enterprise-wide will be affected by these exploits. And again, reputable source. This isn't just somebody's blog that you found says that this piece of software is exploitable and you shouldn't use it. This is a reputable source in the community. All right, so let's go through the top 10 because now I've hyped it up so much. Let's actually get to it. So number 1 is injection. This can be any kind of injection whatsoever. Typically, you think of MySQL injection, but take that up a notch. It's any kind of SQL language, any kind of database, any kind of post or get injection. And typically, all of these will be going to either remote code execution or privilege escalation, something like that. Broken authentication. Broken authentication, again, we're talking general. So any kind of authentication breakage where you're trying to log in and, I can just type in admin and then password 123. That's broken authentication. I would say so. Or if I can type in admin and then not type in a password, that's broken authentication. Number 3 is sensitive data exposure. That can be anything as well. In error messages, in getting a cached site somewhere, in any kind of email that comes across. So sensitive data exposure, XML external entities. We'll get into this one specifically, but this is just allowing an old standard. I mean, I would say raise your hand, but who's heard of XML? Everybody. XML is used by the biggest companies, the smallest companies, the oldest companies, and the newest companies. It is a legacy of legacy systems, and it's still around, and it's very powerful in terms of being exploited and can basically hand you a password file if you do the right things. Broken access control, again with broken authentication, access control. What if I can type / and get to a specific directory on the web server that I'm not supposed to because, who knows, because of any kind of reason, some kind of configuration that an admin did, or because of the fact that nobody thought about this having sensitive data, and then over the years it did have sensitive data. Broken access control, number 5. Security misconfiguration, it goes right alongside that. If the admins on your site aren't up to par and they're giving out the wrong access, or they set something to the wrong access, that's a security misconfiguration. Cross-site scripting, it's probably the most notorious one, it's kind of sexiest one out there. Allows you to execute JavaScript on web pages. There's bug bounty sites that have contests every month for cross-site scripting. It's pretty fun, but also it's pretty dangerous. They can do a lot of damage with this. Insecure deserialization. I can't say that word. Deserialization. So let's just say you're sending some JSON data and you serialize it, and there's some plain text data in there, or it gets sent to the wrong place, or it gets sent in it gets sent in the wrong, there we go, sorry. Yeah, the wrong field. So just insecure deserialization. Using components with known vulnerabilities, think something like WordPress or any kind of plugin. Plugin developed by a third party, and it has a known vulnerability to it that gets published one day, and it works great in your system, but now your system is vulnerable because of this third party. Number 9. Then finally, we have insufficient logging and monitoring. And this one goes out to all the sysadmins out there. Who tails their logs normally? Who watches their logs? What kind of monitoring software do you have on there to analyze your data? Because a lot of times you get indications of things happening to your system way before they happen. You're just not watching it. So insufficient logging and monitoring. All right. So kind of to show you how this affects today, because a lot of those things sounded like disconnected from 2021. So I just did a search on a CVE search website, and I just randomly picked a company, JetBrains, because I don't know, they might have been in the news lately for something that might have happened. Maybe, I'm not saying they did anything wrong. Who knows? Just JetBrains, and specifically Team City. So here's a whole bunch of CVEs from 2021. And if we look right here, we have XSS, cross-site scripting. So in 2021, Team City has cross-site scripting vulnerability in it, as well as all of these other ones. So this is very relevant to the times, and these things are being used by people in the security community, as well as the not so well-intended people in the security community. All right, so let's kind of reel it back a little bit here. So when you're looking at the OWASP top 10, they're going to list these in the order that I just gave, but they're going to kind of break them down. A little description as to what they are, a couple of like real life examples, and then the full scale of what the outcome could be, like how devastating this could be to your system. And so here you go, injection. Injection flaws such as SQL, NoSQL, OS, and LDAP injection occur when untrusted data is sent to an interpreter as part of a command or query. So think of this, like I said, this is something you think of MySQL injections first. That's fine, but now think of anything. Anytime there is user input that you're taking, and here it says sent to an interpreter. Well, that's whatever you have. PHP, Python, anything you have running in Lambda, the interpreter is your code. So anytime that you are getting data from a user, or even from an RSS feed or a JSON input, anytime that is being interpreted and an unintended consequence or an intended consequence by an attacker happens, that's an injection. So the threat agent / attack vector, almost any source of data can be an injection vector. Environment variables, parameters, external and internal web services, all types of users. If you haven't heard of Little Bobby tables, go Google Little Bobby tables once we're done here, and that's how a user can be an injection. So injection flaws occur when an attacker can send hostile data to an interpreter. So again, sending this to your Go script and it's hostile data, it's going to make your Go script do something unintended, most likely malicious, and we want to stop that. So injection flaws are very prevalent, particularly in legacy code. Because think about code that you wrote, or people that you know that write code. Think about code from 10 years ago, 5 years ago even. 5 years could be legacy. Injection vulnerabilities are often found in SQL, LDAP, XPath, NoSQL, OS commands, XML parsers, SMTP headers, expression languages, or ORM queries. So literally anything. Anytime we're taking external data, bringing it into an interpreter, our code, we're open. We're open for security weakness. So injection flaws are easy to discover when examining source code. They are, if you're reading the source code. Scanners and fuzzers can help attackers find injection flaws. So that means that they can help you as well. Scanners and fuzzers. Scanners are automated tools that will go through, find all of your input variables, and just kind of brute force, go down a list and try to find which ones will break it. Fuzzers are the same thing. They kind of, the fuzzing is sending, let's just go for the ease of argument here, like random data. Instead of a username, it's not going to go through a dictionary necessarily or a phone book. It's going to go through and just put in a whole bunch of characters. We're going to see if numbers mess you up, if spaces, if special ASCII characters, things like that. So these things do work. And so if we're talking about chaos and automated, there's ways to automate scanning and fuzzing on all your URLs if they take in variables. You just have to have a list of them. And then there are tools that will allow you to find those as well. So here's my standard injection example. So if you look at this URL, we got example.com, account view, ID equals whatever you want it to be. This looks pretty normal, right? We're taking in some kind of input from the URL. This is going to be the ID, so it could be my first name, could be Gunnard, or it could be 123 user ID. So what if, well, let's take this. So what's going to happen in the back end if I'm writing this in PHP, I'm going to take this variable, and then I'm going to go and run a MySQL query in the database to see if that username exists, if there's a password there, if there's access, like what the privileges are for this user, if they're already logged in, all of those things. But all of that relies on this XXX. So, and I know that XXX is going to go into this MySQL query. So with a little bit of knowing that and understanding of MySQL, what if I do this? Or 1 equals 1. So logically here, we're going in and we're going to search, let's say the code in the backend does a select star from user where ID equals XXX. That's it. So if the user does not equal, if the ID does not equal XXX, it's going to return back and say nothing, an empty result. There's nothing there. So also I could do, so what if I were to change that and say where ID equals XXX or 1 equals 1? Well, in computer programming, in computers in general, 1 equals 1 is, on the Boolean level, it's true. So where ID equals XXX, it's not there, it's going to return 0, or true. Okay, true sounds good. MySQL is going to go, that sounds great to me, and it's going to return back some data that as developers we did not intend, but as the hacker, they go, aha, now I have some information, and you can play around from there. Depending on the errors that are thrown or anything that's returned that's a value, you can just play with this query and get different results. So that's your like standard baseline MySQL injection example. So this changes the meaning of the query. This will return all the records from the accounts table. More dangerous attacks can modify, delete, or even invoke stored procedures. So yeah, so or 1 = 1 and drop table password, or, select star from credit cards at this point. Like, you can do a lot of bad things besides just selecting star. So let's go to the other one that we saw earlier, insufficient logging and monitoring. Exploitation of insufficient logging and monitoring is the bedrock of nearly every major incident. This is kind of putting the human factor into it. If we're not paying attention to our systems are vulnerable. Attackers rely on the lack of monitoring and timely response to achieve their goals without being detected. One strategy for determining if you have sufficient monitoring is to examine your logs following penetration testing. That makes sense. The tester's actions should be recorded sufficiently and understand what damages they may have inflicted. If you go and nmap your system, you should be able to see that in your logs. If you go and try to do an attack on your website, you should be able to see that in your logs. So most successful attacks start with vulnerability probing. Allowing such probes to continue can raise the likelihood of successful exploit to nearly 100%. 2016, identifying a breach took an average of 191 days. Plenty of time for damage to be inflicted. So if we all know about what's happened here in the States with the government and the latest hacking that happened, they trace it back like initially to like 3 weeks is when the malware was put inside, and then 3 weeks later is when it was sent out. Like the malware woke up and started sending out all these information, but the attack actually happened months and months and months before that. So we're talking now months and months and months of little tiny injections. Let's just say a year and a half ago, something happened and they got this software. They uploaded this one DLL that was malicious, and then they went away and they stopped. So there's a little ping in some log files that probably had some errors, but nothing too out of the norm. Then a little bit later, those files moved over again. And so you would have to go back even further to see when these attackers were actually looking at the system and probing the system and trying to find these issues. So think about that time period that the log files would have tiny little blips of information. So you really have to be on your game to look at the monitoring and looking at your log files to figure out when these things are happening. So again, my example earlier of using components with known vulnerabilities. So while it's easy to find already written exploits for many known vulnerabilities, other vulnerabilities require concentrated effort to develop custom exploits. So prevalence of this issue is very widespread. Component-heavy develop patterns can lead to development teams not even understanding which components they use in their application or API, much less keeping them up to date. Some scanners help in detection, but determining exploitability requires additional effort. This is more of a mindset. How many Node.js applications are out there that just run NPM, PHP programs that run Composer, just almost blind? There's historical, Apple was hacked because of NPM packages that were counterfeit, I would say. They went in there with the same name, a newer version. It went right up on the package manager list. Next time NPM was run, they were that payload was installed on the systems just worldwide. Now, it wasn't malicious. It was just going to go out and ping this person and say, hey, I got in. This is where I am. But they did this on a kind of a hunch, like, I wonder if people are even paying attention to what gets installed on their systems when they have so many things going on. So this is more about knowing what you have. As a developer, it's so easy to go, all right, I need to get, for example, I need to get a calendar on this application. Cool. I'm not going to go and write a calendar. I'm going to go and look and see if there's a third-party plugin or package that already exists. So I go out, I find 50 of them. Well, I go and download the one that's the most used because it's the most popular, most up to date. Cool. So now I have that. I know this much about how the code actually works. I just know that it works in my code. And when that developer updates their code, then my code gets updated. So I'm removed from this code altogether. He could put in some really dumb code. It could be very exploitable. And then all of a sudden, I'm open to being exploited. So this is something the development teams have to talk about, be aware of, monitor, and not just go, oh, there's a new version of this out there, NPM update. Watch everything that you do because you don't want to be this person on a team that doesn't understand which components they use in their application and how they work. Trust me, this happens. This is something that is very, very real. And then again, so while some of these vulnerabilities lead to only minor impacts, some of the largest breaches to date have relied on exploiting known vulnerabilities and components. Depending on the assets you are protecting, perhaps this risk should be top of the list. This can get you into a system faster than any kind of research or hacking or fuzzing or probing. All right, cross-site scripting. Kind of covered this a little bit here, but automated tools can detect and exploit all of these forms just by scanning different URLs and which kind of input you're taking. Cross-site scripting is the second most prevalent issue on the OWASP top 10 and is found in around 2/3 of all applications. Automated tools can find them, in all the popular PHP, J2EE, JSP, and ASP. Those are very easy to just have a scanning tool find. So if the hackers can do it, you and your development team or your red team can do it as well. The impact is as severe as where the code is. So if it's just logging in to the front end of a hotel just to check in for breakfast tomorrow morning, not too bad. But if it's if it's finding your passport information and then getting your social security number from that, because lo and behold, you can enter that from your benefits page on a certain airline. It can go pretty deep from there pretty quickly, just depending on the information that's behind these URLs. Security misconfiguration, again, this is just generic admin stuff. Are you not patching things that are known vulnerabilities? Sudo the other day just had a patch to it because there was a 10-year-old vulnerability. How many people know about that? How many people have updated from there? You can go to Gunnard.org, and I have a short thing on how to update that. You should do it quick. Security misconfigurations can happen at any level of an application stack, including the network services, platform, web server, application server, database, frameworks, custom code, pre-installed virtual machines, containers, or storage, literally star. Everything. Automated scanners are useful for detecting misconfigurations, use of default accounts or configurations, unnecessary services, legacy options. It goes on and on. Admin, default password, things like that. That's what we're talking about. So the more layers of systems we add on to things, the more of these are just open, and you really do have to go in and remove them. Such flaws frequently give attackers unauthorized access to some system data or functionality. Occasionally, such flaws result in a complete system compromise. Broken access control is kind of like a broken record at this point. Fix your systems or else people can get in. Access control is detectable by using manual means. through automation, the absence of controls. If you don't have controls, then you don't have any security. Access control weaknesses are common due to the lack of automated detection and lack of effective functional testing by application developers. The technical impact is attackers acting as users or administrators, or users using privileged functions, or creating, accessing, updating, or deleting every record. That's the impact. Either minute or delete everything. So pretty big. Broken authentication. So this kind of, it sounds similar to everything, which it kind of is. It's allowing people in that shouldn't have access, but let's think about it this way. Here we have session management. So session management attacks are well understood, particularly in relation to unexpired session tokens. So how many things are run on sessions these days? Everything. Just the systems involved in just managing and using those are one level of complex. The level of complexity that involves like keeping those things safe and secure and secret, that's a whole nother, and they need to be tested and vetted out. Session management is the bedrock of authentication and access control. Attackers can detect broken authentication using manual means, just by going in and just testing and getting errors, looking at inspect element console. They can also use automated tools with password lists and dictionary attacks. So, story time. RockU. RockU is a great example of what not to do in the world. You probably have never heard of this, but we'll get to, by the end of this, you'll know what it is. So in December 2009, this company, RockU, experienced a data breach resulting in the exposure of 32 million user accounts. The company used unencrypted database. That's, if you're keeping score at home, that's number one error, unencrypted databases, to store user account data, including plain text passwords. That's strike two, as opposed to password hashes. So as well as passwords connected to accounts at partner sites, including Facebook, MySpace, yeah, that's how old this is, and webmail services. So when you go to a site, and now we have, single site login, SSO, where you go somewhere and it's like, oh, log in with Facebook, oh, log in with Google. This is kind of before that. I trust the SSO nowadays, but back in 2009, they were keeping this stuff in a database to make sure that they had the ability for you to connect. So they'd have your password for RockU, and then they'd have your MySpace password, and then your Gmail password, and then your Yahoo Mail password, whatever, all in the same database right there. So that's strike 2, 3. So then also RockU would email you the password unencrypted during an account recovery. So you go in and you say, I forgot my password. Never fear. Just check your email. It's sitting right there for you. Don't do that. That's not good. They also did not allow using special characters and passwords. So we're at like 5 strikes now. Everything about this is wrong. And you can see how we've used this nowadays to change things. So we do learn from our mistakes, and we have learned from this. Also, this is one that can't really fix so easily. The hackers that got this database that was filled with all of these errors and open security flaws, the way they got in was a 10-year-old SQL vulnerability. So what's that? Admins not patching MySQL. Developers, depends on who's in charge of it. Developers could have been the ones responsible, but it's also, if they had an IT department that manages that, they were either lazy or uninformed. Either way, those are not excuses. So a 10-year-old SQL vulnerability got 32 million user accounts leaked. The company took days to notify users after the incident and initially incorrectly reported the data breach, only that the breach only affected older applications, when actually it affected all the users. So when we're talking earlier about, so what's the full breadth of this? If somebody gets in with this kind of a exploit or an attack, what could happen? What's the harm? Well, that's the harm. They used a 10-year-old SQL exploit. Could have been anything. Could have been just a buffer overflow to get in. But once they got in, that database was a complete gold mine. So where's your data being stored? How are you separating it? Are they on separate systems that aren't connected? Are they in the exact same database, unencrypted, in plain text? It's up to you. So XML external entities. Let's talk about this one real quick. So attackers, this is going to be an example of how this actually works. Attackers can exploit vulnerable XML processes if they can upload XML or include hostile content in an XML document, exploiting vulnerable code, dependencies, or integrations. Now, by default, many older XML processors allow specification of an external entity. This is a feature, not a bug. All you need is a URI that's dereferenced and evaluated during XML processing. Okay, what does that mean? So a feature of XML is that you can use it to call something over here. And as an attacker, if I say, yeah, you're going, okay, go over here instead, go over to what I want, that's what this is. So these flaws can be used to extract data, execute remote requests from a server, scan internal systems, perform denial of service attacks, as well as execute other attacks. So how we kind of figure out what's going on is the application vulnerable? The application accepts XML directly or XML uploads, especially from untrusted sources, or inserts untrusted data into XML documents, which is then parsed by an XML processor. So this is how you can kind of quickly and easily look at it, look at your XML itself and see if it has third-party uploads or links in it. Any of the XML processors in an application or SOAP-based web services by default have DTDs enabled. If the application uses SAML for identity processing within federated security or SSO purposes, SAML uses XML for identity assertions, and may be vulnerable. Being vulnerable to XXE attacks likely means that the application is vulnerable to denial of service attacks, including the billion laughs attack. So we're going to look at the billion laughs. I think it's a pretty fun one and pretty straightforward. So the billion laughs attack is a denial of service attack that targets XML parsers. So again, the parser, the script, the code on the back end. And basically it's an XML bomb. It's the exponential entity expansion attack. XML bomb, exponential entity expansion attack, whichever one you want to say. So let's take a look at that. So here we have some XML, pretty basic. And so what we have here, first line, XML version 1.0, standard. Second line, doc type, lulls. Okay, so we're declaring a doc type, we're calling it lulls. And then on the third line, we're declaring an entity, lul, and it contains the string lul. All right, that's fine. Okay, line 4, entity lul2 contains, this contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this contains all of the string lul, which contains lul. We're referencing that variable lul. Okay, so lul2 now equals all of those lulls. Lul3 equals, all of those lul2s, which are all those lulls. Oh, okay, I see what we're doing here. We're just going exponentially more and more and more. We're building a bomb. By the time we get to lul8, we have 10 lul7s, which contain 10 lul6s and 10, and we're just going further and further and further. So it looks, well, it might look strange. This doesn't look harmful to the naked eye. And then we close it off and we say, basically, echo lul9 right here. What that's going to do is going to denial of service attack because it's processing, your XML parser is processing that, and it has no clue what to do. So we're going to get into the mind of the attacker real quick here and kind of get you, if this is, you're not a hacker, you're not that way, but you need to be able to think, as I've just shown, kind of that way in order to protect your own system. So let's get into some fun stuff real quick. OWASP has free software. You can go find it right now. It's called the Juice Shop. And it's a purposely insecure web app. So it uses game theory basically to allow you to go and break in and break into this website using all of these things that we've just gone over. Then you can take that knowledge, go to your application, your system, and see if those things are still there. So this is what the Juice Shop looks like. It's basically an e-commerce site for juice. Makes sense, right? So the first thing that you need to do once you get this installed, it comes as a Docker container. You just install the container, run it, go from there. You can install it as an application. You can run it. You can just run it through the browser on their site itself. So there's multiple ways to use this. The first challenge, it gives you multiple challenges. That's how you progress in this attack. So the Juice Shop is linked to a scoreboard that helps you keep track of your progress and leads you through the different challenges. There's no link, however, to this scoreboard and its challenges. So the first item in the tutorial, it tells you to look. It tells you to look for the scoreboard, and it gives you the hint of looking at the JavaScript. So how I look at JavaScript is through the dev tools by inspecting element and looking at the list of the JavaScript. So here it is telling you, hey, we should go and do this. It definitely holds your hand on this first challenge. It says hit F12 and let's go look at it. So you hit F12, you go and you look and you see all of the JavaScript that's being run. So these look fine. We see runtime, 2015 JS, ES5, ES whatever. We have vendor, we have Maine, we have polyfills, runtime. Okay. So what I would do, I would look at Maine. And I would look at either one of these. So let's go look at Maine just to see what's in there, if there's anything useful to us. Remember, we're a hacker. We're looking for any kind of exposed information, anything that is left out in the open. And it takes a little bit of grunt work, but we're going to go and look through this. So, and again, we're looking for the scoreboard. So if you see up here, it might be super small, but I'm just doing a search for the word score. That's it. Because it is kind of obfuscated. So that's good. It's a plus, makes it a little bit more difficult, but I can also just search. So we have several hits for the word score. And if we look, we see that scoreboard is being returned here and being used here, and it's being used as /scoreboard. And then there's a triple equals, window location. So we're returning this URL to the window at some point. So this looks like a valid URL to me. Let's go type it in and we get to the scoreboard. So that was just information that was out there in the open in the JavaScript and allowed us to go to data in a part of the site that we weren't initially supposed to be able to go to. And we did that just by looking at the source code, which a developer, if they had policies and practices in place, that code should have been gulped. It should have been obfuscated. It should have been minified. It should have been a lot of different things to make it to where the plain text scoreboard was not seen. Also, beyond that, you could have just done it a different way. It didn't need to be done in JavaScript like that. So a couple different things to look at to solve that problem, but finding that problem is what we're here for and what we need to be aware of, because now we're at the scoreboard. Excuse me, if this was like a betting site or a gambling site or something, now we're at a place where we weren't supposed to be, probably. And we could have done some really bad things with this information. What if we're a publicly traded company and this has some potential stock information or benefits information that we get ahead of time? Who knows? Okay, so broken authentication, broken access control, security misconfiguration. These are things straight from the top 10 that we found just in this one. So using components with known vulnerabilities, the scoreboard, when you install it as a third-party plugin, maybe that was the problem with it. And insufficient logging and monitoring. You should be able to know if I'm trying to get to scoreboard and I just type in scoreboard without the dash in there, or I type in final scoreboard, or I start just randomly guessing scoreboard URLs, those are going to come back as 404s and errors in the Nginx log or the Apache log. And if you're not monitoring that, or if you are monitoring it, you're going to see that someone's really trying to get to the scoreboard, find that IP address, and then you can block them or do whatever you want. But that's monitoring and that's logging. That's what it's there for. So final thing to talk about here is ZAP. So like I was saying, OWASP gives you a couple scanners or a scanner and a fuzzer. Another one of its projects called Zed. It's the Zed Attack Proxy, or ZAP. So it's a flagship project, and it can help you automatically find security vulnerabilities in your web applications while you're developing and testing your applications. So it comes free, pretty standard. Download it. You put in your URL. I mean, this is really like low effort. You can do this and step away, go get some tea, come back, and then look at your results. You're going to put in your URL. You're going to, use Ajax spiders. You have a couple different things you can configure here. You can do a slow attack, a fast attack. There are third-party plugins for this. You can do a whole bunch of different shaped attacks or categorized attacks. This is a pretty in-depth program. If you've ever heard of or used Metasploit, it's almost like that. This is a framework where the main part of it comes from its third-party add-ons. So we're going to type in a URL here, and then what we do is we get all of this back. Over here, we're getting all of the alerts, if they're low, medium, or high, where they are. We click on it, we get more information, we get the URL that it hit, we get the label, we get it's a medium error, it's a WordPress, it has to do with a cookie. We get some basic information on it. We can go and Google and do some more research as to what this is, how to fix it, if this really is a security concern, or if this is kind of a known risk that we can take. But we're getting all of this data back straight from them, and all we've done is hit go. We just hit start scan on this. So I'd highly recommend getting this, play around with it. I wouldn't just go and start testing, whitehouse.gov or whatever. Play with your own systems, play on your own systems. Make sure that if you're on a big enough system, make sure that your certain admins know that you're doing this, all of that stuff. But if you do have something you can play around with, I would definitely recommend it. This can be a definite benefit. If you have like a testing server before production, if you have like a silver or a testing, you can run this on that, no problem, on your own development server if you have that. So here's a close-up view of that. And of course, I did my own website. And here it is. It just goes through, and this is everything that it's scanning for. So this, of course, isn't everything. This isn't as in-depth or up-to-date as insanely possible. But this will take you up to about, I'd say, 85-90% of just vulnerabilities in the wild. This is your low-hanging fruit. This is your, oh yeah, I forgot to remove that account, or I need to change the permissions on this certain directory, things like that. So this will take care of that for you. I mean, it won't solve them, but this will let you know that they're there, so that it'll just save you time from guesswork. Like, where do I begin? This is where you begin. This is where I would recommend you begin. So, conclusion, all developers and anybody out in the chaos engineering world should be aware of this. You don't have to be 100% knowledgeable of it all day long. Be aware of it. Have it be something that you know how to go and navigate the OWASP website, look for these things, and when they come out. Internal pen testing should be a part of your CI/CD. I don't know why that's backwards. You can have a lot of these things are command line, and a lot of these things can be tested automated wise. So when code is being compiled and developed and put together into packages, you can definitely run this stuff through a pipeline in order to test it. And if not that, it should be part of your QA. If you have a red team, it should be part of what they do as well. There are ways to definitely procedurally do this and not just haphazardly, hack at stuff. There's definitely methods and ways to run scripts and document what is being tested and how tested, how trusted these things are. Zap, get it, just install it locally and see how it works. I would definitely say to do that. LINPS, which is a Linux script that does escalation, user access escalation. So you get onto a system as guest, you run LINPS on that system, and you will most likely either get root or another level of access pretty easy. It's pretty fun command line script. Nmap. I would bet the majority of you already know what Nmap is, but if you don't, go look it up, download it, become comfortable with your generic -S scan just to figure out what ports are open. Nmap is a port scanner that really tells you some detailed, granular information about what ports are open on your service, on your server. Very useful. Security policies should be templated, in my opinion, from the OWASP top 10. If you can knock those out, get them written down, and show that your policy adheres to this top 10, then you've mitigated a lot of damage and what could happen to your system. So that's all I got for you. Again, you can find me on the internet in general. What I don't have on here is Gunnard.org. I post things that I think are interesting, whether it be security related, programming related, or just internet related. But you can find me there as well, and links to my book if you happen to be a PHP developer or want to know about PHP 8. I would say go there and check it out. I'm going to look at the QAs here real quick. We have how to prevent breaches due to failure and restricted URL access. So how to prevent breaches due to that would be, I would say, yes, restrict URL access. That also goes into monitoring your logs. Because like I said, if you're trying to hit URLs that are going to return errors, if your security is set up correctly, then they're going to show up as 404s or restricted or whatever in your logs. And then how to mitigate SQL injection risks. That is really, it comes down to scrubbing your input. User input should never be trusted. I don't care if you're already logged in, if it's just an internal company website, never trust user input. It needs to be scrubbed. It needs to be checked. It needs to have all special characters taken out, backticked, quoted, all of those things. You need to make sure that you're scrubbing user input all day long, every single time, no ifs, ands, or buts. That's how you mitigate a majority of your SQL injection risks right there. Other than that, yep, that's all I got. And I see my hosts are back. Welcome, guys.
So that was a great session. I think we overshot the time, but that's all right. Also, so if you want to continue the conversation or have some more questions for him, please join the session-specific Slack channel that we have. And yep, we're good to go, I guess.
Yeah. Thank you guys very much.
Thanks, Gunnard. Thanks. Bye.
Bye.
Thank you, everyone.